We're going to talk today about rate of change, which has been defined as the relationship between two changing quantities. And we have found that this also is another name for slope of the line. Slope is defined as the change in the y's divided by the change in the x. And so when we relate rate of change with slope, we're finding that the two changing quantities are the dependent variable and the independent variable. So if we look at the coordinate plane and we see the y-axis is my vertical axis and my x-axis, the horizontal axis. When we talk about rate of change or slope, we are talking about the horizontal axis as the independent variable. We've also said that our x-axis or our x-coordinates are representing our input. And another name that we've found for our x-coordinates is our domain. The y-axis or our y-coordinates are our dependent variables. They represent our output. We've called the y-coordinates a function of x because they depend on x, and our notation for that is f of x. And finally, another name that we have used for the y-coordinates is range. And so when we graph a line, like this, we can determine the rate of change by comparing the change in the y to the change in the x. And we can do that a couple different ways. So again, just a reminder, the slope is the vertical change over the horizontal change. And we've also used the terms rise over run. Rise is representing change in the up and down direction. Run is like we run on the ground, which is horizontal. So rise would be our vertical change and run is our horizontal change. So on a graph like this one, if I see the line passing through particular points, for example here the coordinates of this point are -5, 0, and the coordinates of this point are 0, 3. So I can algebraically solve this as the change in y, get to a blank page, change in y over change in x is equal to, we can say, y coordinate of 0.2 minus the y coordinate of 0.1 divided by the x coordinate of 0.2 minus the x coordinate of 0.1. And so using the points from that line that we were just looking at, the points we determined again were negative 5, 0, and 0, 3. If we use those coordinates, we can show slope algebraically by 3 minus 0 divided by 0 minus a negative 5. 3 minus 0 is 3. 0 minus a negative, that becomes positive. So 3/5 is my slope. That's one way to determine it. Another way is if we go back to the graph, we can actually walk from point to point and determine the slope that way. So if I, for example, am starting on, I have to be on the line. If I start at the point negative 5, 0, and I want to walk to my other point, 0, 3, I'm going to walk vertically and then horizontally until I get from point to point. So for example, I'm going to walk up 1, 2, 3. Because I walked up, that's a positive direction, positive 3. And then I'm going to walk to the right, 1, 2, 3, 4, 5. Because I went to the right, that's also a positive direction, so that's positive 5. And if my slope is determined by rise over run, that's a positive 3 over a positive 5, which is 3/5, same as we determined algebraically. Because it's a straight line, that same walk is going to occur from point to point. The entire line has the same slope. So if I want to get to this point, for example, I would walk up 3 over 1, 2, 3, 4, 5. Same thing, I want to get to this point. Up 1, 2, 3 over 1, 2, 3, 4, 5. If you noticed on each of those, I was walking from left to right. Just like we read a book, we read a graph from left to right. And so when we're looking at the different possibilities of lines, there's 4 different orientations or general directions of slopes. This first line depicts a positive slope. If I start on the left and I follow the line, I'm going upward from left to right. And so again, if I'm going to walk the line in order to get, say, from this point to this point, I am going to walk up positive direction to the right positive direction. So a positive over a positive is a positive slope. This line, on the other hand, if we go from left to right, we're reading down. So if I want to, and again, if I want to walk from point to point, we're going to find this type of line has a negative slope. We are decreasing from left to right. If I'm going to walk this, if I go to, if I walk down, that means I'm going in the negative direction. And then I walk to the right, that's a positive direction. And so a negative divided by a positive, that determines a negative slope. When we have a horizontal line, think about a skier. This would be a cross-country skier. The hill is not helping him or her increase their speed. The cross-country skier is having to do all the work. The rate of change helped by the slope is 0. Horizontal line, every horizontal lines have 0 slope. And if we do that algebraically, the change in the y direction, there is no up or down movement, and so that would be change in y is 0 divided by any constant, any number that we would choose to put in the denominator. If we divide 0 by any number, we get 0. And then finally, vertical lines. Again, if we're going to use the analogy of a skier, I wouldn't want to be a skier on this slope. This would be a closed ski slope. They wouldn't let you on it. So a vertical slope is undefined. Okay, if we do that algebraically, you'll notice on a vertical line, there's absolutely no change in the horizontal direction. Every x coordinate is the same on a vertical line. And so algebraically, that would look like any constant would be my numerator, and I'm trying to divide by 0. We can't do that. And so this is undefined. So any vertical line has a slope that we call undefined.